Today, we're diving into one of the most surprising new findings from NASA, something that might completely change how we understand the sun's solar cycles. For decades, scientists believed they had a pretty good idea about the 11-year solar cycle, a rhythmic rise and fall of solar activity, including sunspots, solar flares, and coronal mass ejections. But new observations suggest that the sun might not be behaving the way we thought. Instead, it's showing extreme, unexpected activity that could have huge consequences for Earth, our technology, and even space travel. So, were we wrong about solar cycles? Let's break this down step by step. Part 1. What we thought we knew about solar cycles. For over 200 years, astronomers have tracked sunspots, dark, cooler regions on the sun's surface caused by magnetic disturbances. Every 11 years, the sun goes from a solar minimum, quiet, few sunspots, to a solar maximum, lots of sunspots, flares, and storms. This pattern is so regular that scientists use it to forecast solar storms and space weather. The last solar cycle, cycle 24, was unusually weak, leading many to believe that our sun was calming down. So naturally, many expected cycle 25, which began in December 2019, to also be weak, maybe even weaker, but that's not what happened. Part 2. What NASA just reported. NASA, along with NOAA and ESA, has been closely monitoring the sun with spacecraft like the Solar Dynamics Observatory, SDO, and the Parker Solar Probe. What they're finding is shocking. Cycle 25 is far more active than predicted. Instead of being weak, the sun is producing sunspots at double the expected rate. Some of these sunspots are giant, 10 times the size of Earth. We've already seen multiple X-class solar flares, the most powerful kind, far earlier than scientists expected. Solar wind streams and coronal mass ejections are bombarding Earth's magnetic field, creating auroras much farther south than usual. In short, the sun seems to be revving up, not calming down. Part 3. Why does this matter for Earth? Solar activity isn't just a curiosity for astronomers. It has real effects on our daily lives. Knockout power grids, like the famous 1989 blackout in Quebec. Interfere with aviation and radio communication. Stronger solar winds can also threaten astronauts and future Mars missions with dangerous radiation. And here's the scary part. The last time we had extreme solar activity, the Carrington event of 1859, telegraph systems worldwide caught fire. If something like that happened today, it could cause trillions of dollars in damage to our technology-driven society. So, if NASA is right, we might be entering a much more volatile solar period than expected. Part 4. Were we wrong about the solar cycle model? So, what's going on? Why is the sun misbehaving? Well, the truth is, the 11-year cycle was always a simplification. The sun is far more complex. The cycle is driven by the sun's magnetic field, which flips every 11 years. But the way this magnetic field twists, tangles, and reorganizes is influenced by many chaotic factors, like plasma flows deep inside the sun, rotation speed, and possibly even influences from cosmic rays or the galactic environment. Some scientists now think the sun might follow longer supercycles, spanning 80, 200, or even 400 years on top of the shorter 11-year cycle. For example, the Maunder minimum, 1645–1715, was a period when sunspots nearly disappeared for 70 years, coinciding with the Little Ice Age on Earth. On the other hand, there have been times of hyperactivity, with solar storms much stronger than anything in recent centuries. So, it's possible that we're entering a new phase of heightened solar activity that wasn't fully accounted for in earlier models. Part 5. What NASA's probes are telling us. Thanks to missions like the Parker Solar Probe and ESA's Solar Orbiter, we're finally getting up-close looks at the sun like never before. Here are some surprising findings. Parker has discovered that the sun's magnetic field switchbacks unexpectedly, bending back on itself. Solar Orbiter has captured the smallest solar flares ever seen, suggesting there may be a spectrum of activity we barely understand. Data shows that the sun's corona, outer atmosphere, is far more dynamic, with constant explosions of plasma at multiple scales. All of this hints that the sun's behavior is much more chaotic and unpredictable than our simple cycle model suggests. Part 6. The bigger picture. So, were we wrong about the solar cycles? Not completely. The 11-year cycle still exists, it's real and observable, but it's not the full story. Instead of a neat, predictable rhythm, the sun seems to follow layers of cycles, chaos, and magnetic interactions that we're only beginning to understand. This matters because the sun is literally the engine of life on Earth. It powers our climate, influences cosmic radiation levels, and shapes space weather that impacts our technology. Getting solar predictions wrong could mean being unprepared for the next supersolar storm. Part 7. What's next? NASA is already updating its models, and early predictions suggest that solar cycle 25 may peak earlier and stronger than expected, possibly around 2025 into 2026. If that's true, we could see more auroras lighting up the skies around the world, higher risks of satellite damage, a chance to finally study a more active sun with modern technology, giving us data that could protect us in the future. In other words, this might be the most important solar cycle of our lifetime. So, were we wrong about solar cycles? Yes and no. We weren't wrong that the sun has cycles, but we were wrong to think they were simple and predictable. The sun is reminding us that it's still a mystery. A giant nuclear furnace, 150 million kilometers away, that still has the power to surprise us. What do you think? Are we headed for another Carrington-level event? Or are these just natural fluctuations that we'll learn to live with? Let me know in the comments below. And if you enjoyed this breakdown, don't forget to like, subscribe, and share this video with someone who loves space as much as you do. Stay safe, stay curious, and I'll see you in the next video.